Thank you for the introduction. I'm very sorry to be here so late on Friday evening. I'm certainly as tired as you, so I would like to try to make this like dynamic, so you can interrupt me at any time. And I have made the following plan. I would like to bring you into the question of scenarios, because this is something that is very used and sometimes that is very useful in the context of climate issues. And so I would like to present you this in four steps. So the first one, as I was an IPCC author in the last assessment report, I would like to bring you back to what is IPCC and main results that are have been assessed for the last report very quickly, because I suppose that you're familiar with that. And then I would like to bring you into what is the question of the future and what is what we call in French prospective. And I don't have the good translation in English, even foresight. I'm not really happy with that. I would like to try to explain my point. And then I would like to bring you to different kind of scenarios that are built to enlighten that future. So the IPCC scenarios, the so-called IPCC scenarios, and I would like you to be aware of what there is behind. I would like to bring you back to France, because you're in France, and some elements that we have done and some results that we have bring in my lab are, I think, interesting. And then at the end, if it's not too long, I would like to present you work that has been done with the RED team, so the RED team in English, but it was a French team. And it was done because the Ministry of the Army and the Defense wanted to associate cartoon makers and scientists in order to think about scenarios of the future. And it's a very different way of building scenarios. So I will show you this in a little movie and explanation. Okay, so why do I want, so I have to find my English, sorry. Why do I want to tell you things about IPCC? IPCC is a group of scientists that are here not to give their advice, but just to assess science and to bring a diagnosis of science. And that's very important to understand how you read the IPCC report, because what is the most important is what is in the brackets that you find linked to each result that is in the IPCC report. As we are here as scientists to give neutral assessment of each of the scientific results that we put in the summary for policymakers, so I will not go into the detail because it's going to be too long, but the famous abstract that the policymakers and decision makers read is this summary. And in the summary you will find under brackets what is our believed in terms of confidence and in terms of likelihood. Confidence is a level that you give if you're not so sure of a result. What do I mean by not so sure? Meaning that there are not so many studies, or the studies that are existing are not bringing the same trend. So you have this tabular here that goes from really the bad assessment, low agreement, limited evidence, to the highest one, high agreement, robust evidence. And you find this under brackets in the IPCC report according to what is the assessment we give to the result you are reading. So that's very important because a lot of people and in the media say IPCC says that. If you don't precise with what level of assessment, what level of confidence, it brings nothing as information. And so when you have reached this level, then you can assess better the results you're talking about, because you can bring quantitative metric, and then you can have this assessment that is given in a sentence with words, but that correspond directly with probability. So for instance, if you find that it is very likely that, for instance, climate change is due to the activity of human beings, that means that we know that with 66 to 100 chances in terms of probability. Okay, so this is kind of important. And when this adventure has begun, the first result that was discussed in the first assessment report was this question of, is there a link with the growing of the greenhouse gas and the human activity? And so now that we have reached the sixth assessment report, we can say that it is very likely that this link is direct. Okay? So this is how the scientists, from year to year, enhance their knowledge thanks to the research that is conducted. So if you're aware of what is happening in IPCC, you know that there are 3 working groups. So the first one is dedicated to the basis of climate in terms of physics of climate. So mainly climatologists are embedded in this group and in this work. The second group is dedicated to the consequences of climate change, meaning that they're working on adaptation, and people are more coming from geography, social science, and people from infrastructures, engineers, and that kind of specialties. And then you have the third group that is dedicated to what? Attenuation, reduction of the greenhouse gases, and the solution to reach this attenuation. And then you have the synthesis report that gives the synthesis of these 3 reports. So people are completely lost because journalists are announcing, like, the IPCC report is released, and then 6 months later, the IPCC report is released, and then 6 months later, the IPCC report is again released, but it corresponds to the different working groups. And so, just very quickly, I would like to give you some, I skip because I know that we have only 1 hour. Just the main result that I would like you to really see. So you find this in the different working groups. And I suggest then, rather than reading the IPCC report, you use a search key with keywords in order to find a lot of information, and it's full of very interesting information. So the first result that comes from the observation of the past is linked to the rising of the temperature. So I suppose that you know that. And so that was what, with my comments, I was saying it's very likely that the human influence has won the climate at a rate that is unprecedented in at least the last 2,000 years. And beside the observation that we have, we look also at the impacts that can occur related to this level of temperature rise. And here you see that you have also for this impact the medium confidence here in the question of impacts on agriculture, fire weather, the likely assessment in the increase of heavy precipitation, the very likely for global sea rise, glacier retreat, and virtually certain for the acidification and the increase of hot extremes. So you see that we don't have the same level of confidence for the result for each element. For the second working group, I picked this result. So I told you about this adaptation focus group. And this result is also something that is highly certain. The fact that half of the population lives in a hotspot of high vulnerability of climate change. What does it mean? It means that they are the most fragile and they are the most vulnerable. Meaning that if you have high precipitation in a country that is fragile in terms of state and that is vulnerable because it is very possible that climate change will occur here, if they don't have the means to protect themselves, there will be more hazards and more impacts on the population. And what we call the injustice is the fact that they have historically contributed the least to the climate change. And again, with this evaluation, you have for the consequences, so I will not comment all the slides, you will have them, this level of confidence that is given by the dots here, from low confidence to high of very high confidence, saying that science is a place where the doubt can be present, and because of that, you will have to continue the research in certain direction to give more elements when it's not so clear if it's yes or no at the question raised. So last result that I would like to share with you for working group 3, just to illustrate the difference of the work. So I did not precise that in working group 3 you have more engineer, economists, because you're tackling the reason of the emissions, so all the sectors producing energy and producing elements that have these impacts, and also economists, because there is a discussion about the solution to mitigate these emissions. So here I would like to bring your attention on the way you present the results. So you can manipulate very easily the graphs and the figures according to what you want to defend. For instance, if you see here on the left, you have the level of emissions, so it's the net anthropogenic GHG emission per capita, and for total population per region, and it's given for the year 2019. So what you see is that you have a rank where North America is at the top, and you have here, for instance, Eastern Asia, that we know is a very high emitter, that is at the third place because it is per capita that these figures are given. But you can also have another will of illustrating what has been the historical problem. if you bring the CO2 emission per region, and from the beginning of the Industrial Revolution in the 1850 until today. And then you see that the classification is different, because you have the places where this use of energy mainly has been done that are arising at the first place, and you have the places that have developed themselves later that are at the bottom of the ranking. So you have a lot of results in the question of climate, and you must be very careful through the way you will use it, because if you want to give something that is neutral and that really brings discussion open, you have to give all the elements of the discussion. And so one of the main results also for Working Group 3 is that saying that there are options available in every sector that can at least halve emission by 2030. So how to do that? That is now the question I would like to focus on. And in order to do that, so 2030 is a future that is really like in 5 years. So we used to talk about 2030 and 2050, and we continue to talk about 2030 and 2050 as if we were in the year 2000. But I'm very sorry, we're in 2025, so for me 2030, like, it's done. So it's going to be very difficult to continue to have this kind of saying, and we need to talk about maybe 2070 or 2100 in order to bring relevant vision for the future. So very quickly, I would like now that I have give really general result for IPCC, but with the point on the assessment way we work, I would like to give you some reflection about the question of the future. Because people are talking about scenario, but you don't know the way they want to tackle that future. So for me, and for some famous French people, so Pierre Massé, for instance, he was an economist and a mathematician, and he participated to the reconstruction of France after World War II. And he was heading the Commissariat Général au Plan, which is the main place for the planification, which was the main place for the planification at that time. So he had a way of presenting the way we need to think in order to build a strategy. And he was saying that in order to go to an action, to take an action, first you need to think. It might be trivial for you, but it's something that is worth to say. And how you think, you try to evaluate all the possible future outcomes of your strategy, of your decision. And I'd like I like the analogy with a chess player, because I don't play chess, but I know how it works. And I have understood, good chess players can contradict me, but that the question is to try to figure out your adversary, what is the strategies that it has. And if you know all the possible strategy while moving one piece of your game, then you can win. And this is why computers are so good at anticipating the opponent's reactions. So the problem that we have in the question that we tackled when we talk about climate and the problem, the complex problem, climate like biodiversity, the question of attenuation, the question of adaptation, is that we are in a game where the rules are modified during the match and the pieces change in number and nature. And that makes things very, very difficult to handle. So another guy that I like very much, another French guy, Gaston Berger, and he was, for some, the father of the prospective process. He was saying in the 50s already that our civilization is like a car constantly accelerating on an unfamiliar road at night. It needs headlamps to throw light further and further ahead to avoid a disaster. And if you just learn this sentence, you have the key of why it is interesting to build scenarios. This is because we need to face the future and we need to understand that future in its original nature, and we need to apply to that future methods that are different than what we did for the past and for the present. So let me clarify that process that gives a synthesis of these prospective disciplines. So the procedure is, first you explore the future from our knowledge of the present and the past. And secondly, you examine the possible evolution according to what? To the decision you want to take and the actions that you carry out. So this is why it's very important to understand that this step of looking forward is the most the thing that you need to concentrate on before taking any action, any decision. And why do I insist on that? Is because a lot of decision makers, of policy makers, they take decision and then they look at the consequences of the decision. I will come back to that because we had here an event that all the people remember, which is the Yellow Vest movement that has been triggered by decisions that were not made with any perspective beforehand. So, I would like also to insist on the fact that a lot of time, people that make perspective, they mismatch perspective, prediction, forecast. Perspective, we said, it's a preparation to action, and it's an idea of facing the future. So if you want to prepare an action, you don't think that the future is already written and that you just have to wait because you cannot change anything. So this is the way forecasting works. It has been derived for oracles at the very beginning, and then calculation of the trajectories, and then it's very useful for weather forecast because it's a real forecast. But in the question of climate change, we cannot forecast anything from now to 2100. We need to be serious. We don't even know what is going to happen like in 20 years because of a lot of elements that are not under control. So when you look at a scenario, just remember that we are not trying to discover a future that is already written. So for the perspective, we are always in the thinking that we are going to build the future. And so we can consider the future as a kind of observatory which can look at the past that lead people, society, towards it. So we don't guess the future. Remember just that. We're not guessing any future. We're participating in the creation of that future. Having said that, what are these famous IPCC long-term scenarios? I suppose that you might be familiar with that kind of curves where you have, okay, so we have here from 2000 to 2100. In the y-axis, we have what the gigaton of CO2 equivalent. And why do we have so many curves going in such different trends? Do you know why? Yes? Go ahead. Okay, so yes, that's one part of the answer. So there are a lot of trajectories that are considering very different worlds, so very different assumptions, and that are trying to assess what would be the consequence of different kind of commitments for the different governments. But there is also other answer, and I will come back to that. But these trajectories, so there are 1,202 trajectory exactly here, are divided according to the level of warming that they lead to. So you know the correspondence between the degree and the level of greenhouse gas emission, and don't come back to that. So you have these categories that are around the 1.5 degree of warming, the 2 degree, then you have a higher level of warming, and at the end you have 8 categories that are the classification for these different scenarios. They are divided in 8 categories. Okay, and they are presented all together in one graph. And in fact, these scenarios, I would like to precise where they are coming from, because yes, they are coming from different assumptions, but they are coming from different modeling approaches. And these modeling approaches are what we call integrated assessment models. And these integrated assessment models can be very different one from another. So you have one type of model that integrates everything, and you have models that are dealing with different components. And you have also behind assumption describing how the society is evolving. I don't know how much you're familiar with these models, but I would like to try to present them very quickly in order to be clear with what is behind. So, okay, we are trying to assess the global impact of climate change. What do we need to capture? First, we need to describe the socio-economic development of our society. And this is what will have consequences, because now we have linked that with this very likely result in terms of emissions and land use. according to this level of emission and land use, you can translate that in terms of climate change, rise of temperature, rise of the sea level, and this will have damages, and these damages, you can take them into account in order to give them costs that will come back to your development and will have effect on the development, and some models do that. And you have also the possibility to adapt yourself to these damages, and then you have costs that will link this development with your climate issue. So this is a very simple scheme. And when you have the willing of describing this process, you have what we call the influence factors. What can influence that? There is first the level of medication that you can use in order to address the question of emissions. And so it is directly linked to the mitigation potential. You have what we call the socio-economic pathways, and some of you have heard about that, the famous SSPs. I will come back to that. And so this is describing, so you were saying the level of pledge and the commitments, but it can describe the non-commitment of a society also. You have the choice to bring a value to the discount rate. Do you prefer the future generation, or do you prefer the present? And you also have some uncertainty on the climate system in terms of the solar issues, the precipitations. And you have also the choice for your damage curve, how the damage occur at a function of the climate change. How do you link the climate change and your damage? Because if you work on this subject, you can see that it depends on the region you're talking about. So that gives the influence factors that are linked to this presentation of the different modeling approach. So when I said integrated assessment model, it means that you consider everything together. And the more you aggregate the different elements, the more you need to approximate. Because if you're talking about, for instance, here, the climate change, you cannot use a climate model that is very consuming in terms of calculation, in terms of equation, in terms of parameters. So if you want to take into account climate change and the socioeconomic development with the mitigation, the emission and the damages, then you need to simplify more what you are trying to represent. So when you consider all together, it's an integrated assessment model. And if you consider the different components, then you have more specialized models that are used in the different working group. So for instance, very clearly, the first here climate description is used by the climatologist in the working group 1. If you work on damages, you're in working group 2 because you're thinking about the consequences of climate change. And very clearly, this one about mitigation concerned working group 3. So that means that behind the curve and behind the trajectories, you can have very different models. And now I hope that you're beginning to understand that we have put 1,200 trajectories coming from different modeling approach on a same illustration, meaning that we are maybe comparing pears and apples. Okay? So, I would like to just present you more these influence factors, because these are the factors where the uncertainty comes from. So when you have mitigation potential, when you have this climate uncertainty, you don't know exactly what is the level of rising coming from a certain amount of gigaton of CO2. The socioeconomic development, I will come back to that. The damage curve is a very difficult discussion. You have insurance risks, departments in a bank and finance, they're working on that. And the discount rate, I don't comment because it's something that you might know certainly. So now, behind the model, you have the scenario methods. And there you have also different school of thinking, different communities. So you have the probabilistic scenario development approach, and you have the one that prefer to have alternative scenarios in order, remember, we are trying to enlighten the future and to enlighten the possible future and alternative vision of it. So here, probability is saying that people prefer to know what is the most probable scenario. So the problem we have here is that we're talking about the future, and so they propose to have many scenarios together, and then to address them with these evaluations in terms of probability in order to bring results like the one that was mentioned here. For instance, you need to know, as a decision maker, what is the probability that an asteroid will destroy the planet? Yes, but in the question we raise, this kind of result is very difficult to establish. So we are preferring the second one, because this uncertainty in the factors brings really the idea that it's better to build storyline very different based on different scenarios. And this is exactly what is done in most trajectories that you see. So now, to be more concrete, what do we do in terms of dealing with these influence factors? For the damage, for instance, you have two factors that will impact damages. First, you have the socio-economic condition, and then you have the climate condition. And this is what has been done with the SSP, the socio-economic pathways, that aim to describe the world with the different storylines describing the society and the relationship between the different parts of the world, with the forcing level. So in order to lose everybody, we were talking about degree Celsius, and now we're talking with watt per square meter, but there is a correspondence. The higher you are, the higher the rise of the temperature. And so these climate and socio-economic conditions are linked in order to describe the influence factors, and are linked in a way that we bring a reference for all the modeling teams that want to compare their result. And so there were 60 people that gathered in Denver, it was in 2014, and that brought a description of the socio-economic way that have challenge for mitigation and challenge for adaptation. And these socio-economic ways were this organization that have been described in the law challenges for adaptation and mitigation, because everybody is taking what they call the green road. The highest challenges where there is a rocky road with regional rivalry, SSP3, and so this is also the acronyms that are very used in the IPCC scenarios. SSP1, SSP2, intermediate challenges, middle of the road. SSP3, so the highest challenges. SSP5, we continue in the development of fossil fuel. SSP4, there is inequality and the road is divided. And so there was a very big work done on the description of each of the SSPs in order to enable their translation in terms of quantities for them to be introduced in quantitative way in the models. So here I will not comment too much, but you will see the consequence on population, on equities, on dietaries, on the renewables deployment, on the technology deployments that are specified and precised in the SSP 1 to 5. So in abstract, there are 5 possible futures about 5 possible stories about the future, and maybe we can imagine the one we are in. Given that, 2 models have been used, one from the OECD, the other one from the International Energy Agency, to translate these stories in terms of quantities. Quantities as trajectories of incomes, trajectories for the evolution of the population, trajectories for the primary energy, and trajectory for the land use. From this trajectory, we can then assess different models with this data, and we find in the 1,202 trajectories, the trajectories that has been built using this SSP, and it is clear that they are bringing to certain level of forcing radiation force, which correspond to warming levels. So you see that, so these models, there is a big story about that, but they have been picked just in order to illustrate what can be, what corresponds to what level of warming. So this is why we call this trajectory illustrated mitigation pathway. Illustrative mitigation pathways are trajectory that have been picked and that correspond to different SSPs. So you remark that in order to be not too warm, we need to be in a SSP1, meaning that we need to be in a peaceful world where we cooperate globally, the technology is developing rapidly, we have strong environmental policy, no inequity, etc., etc. So that brings you in a better world than the one that corresponds to SSP5. SSP5 is the catastrophe, and that brings us to the highest level of warming. So you see here that in the big figure of all the, with all the trajectory, if you pick some of them, then you can begin to understand what is the future that it is enlightening. In order to understand what is the future enlightened, you need to work a little bit, because you had to listen to me, to understand that there are specific models they are based on, specific assumptions they are based on, and then you can have some elements of reflection in order to build your decision as decision maker. But if you have this consideration of the whole picture of the different trajectory, saying that some are very high, okay, some are very low, very nice, and all together they are put in the same illustration, it's very difficult to bring any advice from that brutal way of presenting things. Okay, so the scenarios, I just suppose that, but now it's written, are translated in terms of temperature warming for the century. So you had understood that those that were low were corresponding to 1 to 2 degrees, and then we are over 3 to 8 degrees of warming. And there is also a consequence on that, is the fact that you have impacts that are worsened because of this raising of temperature. And this is one of the message that the IPCC wanted to bring. The fact that if the temperature increases, then the impacts are increasing, then the next generation will have more and more difficulty to adapt to the environment they will live in. And so the fact that every increment of global warming will intensify the concurrent hazard. So now really to conclude on that, I would like to explain you precisely how, as researcher, you can bring one of your trajectory in the whole bunch of trajectories here. So when the IPCC report on begins, like now they're beginning on working on the 7th IPCC report, there is a database that is open to anyone who want to submit the results of its model. So this database is hosted by IIASA, that you might know, the International Institute for Science, for Applied Science and Application. And no, I don't remember both. So anyway, you know them, in Austria. And so what is happening is that at the very beginning, so they just take scenarios with data, okay? It's not like stories, huh? It's data. So at the beginning, you have 2,266 scenarios. And there is first an initial vetting that says that, at least, guys, you need to be in intervals that are coherent with the historical trend. So for instance, if you are in a scenario that talks about 2025 and that has 50% more than what we consume in terms of energy in 2025, we say, no, I'm sorry, we don't take your data. Okay, so from the first vetting, there is only 1,686 scenarios left, and these come from more than 50 model families. So you see that there is a very high range of models that are here. And then the question is, how do we compare these scenarios? We want to translate the level of emissions that are given as output in terms of level of temperature. And for that, there is magic, an emulator of climate model that makes this translation according to the fact that you have brought all the needed greenhouse gases emission in your results. So if you don't have that, you don't pass the second vetting. This is why from that number of scenarios, only 1,202 scenarios are left at the end. Okay? So you understand the process. And now these scenarios, they are coming, we said, from very different ways of modeling. I will come back to that. And they are arranged in two categories. So here you see the C1 to C8 categories. Remember, it was the categories for the level of temperature. And you have, for instance, 97 scenarios in the first categories, 311 in the third one. So do you think that it means that it's more probable that we will be in this category in the future rather than in this category in the future? The fact that we have more scenarios in the categories around 3 degrees. Who wants to jump in? Yes?
I would say not necessarily, because I think it's just the number of models that are coming with this trajectory, right? So it depends on like confidence and so on.
Very good. That's very important. So it has nothing to do with the probability of occurrence of any of these categories. It just says that this part of the room was more interested in specification and assumptions that have led to that level of rising. And there were less people wanting to, for instance, constrain their model in order them to fit into the 1.5 level of warming. And so that brings also misunderstanding for the policymakers, because there is no real indication behind these data. Then the fact that researchers are more interested by that question rather than the other. This is why when we say IPCC scenarios, it's false. It's the model from a laboratory in UK and the model from a laboratory in Australia and the model for a laboratory in Algeria. And these people are just guessing or trying to understand the future with assumption that they have themselves. And there is no command, there is no control on that. It's just what is existing in terms of research at a certain point. But we can say also that, for instance, if there is not enough work done on 1.5, then the researcher will propose more scenarios according to 1.5. They will work on that, okay? So this is the emulation, the natural emulation in the research community. So remember that the IPCC scenarios were not designed to be a single, coherent collection. They can be seen as ensembles of existing model runs that were not created to be an ensemble. And this collection of data is an arbitrary collection. Okay? So they will not encompass the full range of future. And they will treat the set of questions that are in the mind of the researcher. And some of them can rely on the SSPs. So these are the scenarios that I have, the socio-economic scenarios that I have described. But some others, they don't take SSPs as reference. And then, okay, we can discuss that because there is a lot of discussion. Some researchers believe that they will have more chance to be published if they use SSPs because it's more recognized in the community. And that can create a bias. So just to remember, the scenarios brought together are presented in that way in order to to bring elements about the fact that if the temperature will rise more, then there will more chance that people born in the 50s, 80s, 20s encounter difficulties to adapt themselves in the forthcoming world. Okay, so I don't know what time is it. 5-10 minutes. So maybe I will. I will do that very quickly, just to show you something, just to talk about something, which is the fact that usually also in scenarios for a long time, researchers were focused on the offer side, so on the technology potential to mitigate, and the reflection about the demand side has come like since 15 years maybe, and more today. But the fact that lifestyle can be at the core of the carbon neutrality challenge is very new. And we have done a study on that for France. So very quickly, we talked about a model that represents scenario for the future of energy in France. And France has this pink characteristic, which is its nuclear share in the primary energy. And France has a problem, like like a lot of nations, that it has, so I skipped the target, but we have a very, what we call ambitious target. Oh, okay. Yes, so the ambitious target of this carbon neutrality after 2050, and we are very far from it. So I'll come back to the yellow vest. Because, okay, so this is the emissions, and this is the 2050 target, the carbon neutrality target. How are we going to do that? So we have proposed to think about that with a prospective exercise, looking at the future, discussing about lifestyles. And so that was work that has been done with a few of my PhD students that have linked together different models. So I will not go into these details. And that have proposed a description of the society that can evolve in a trend of digitalization and or in a trend of collective society. So what do we mean by that? Okay, so the digital society, they will, so everybody will have the same assumption on demography, but in a digital society, more single households, higher equipment levels, more virtual activities, greater place of work in society, preference for urban centers in cities, higher living standards, and development of long-distance destination. Do I refer to something real? I don't know. And the collective one is something where the human and the relationship with the work is completely different. So there is a development of the shared form of habitat, maintenance of the contraction of the activity area, the reduced place of work in time organization, reduction in semi-urban areas to the benefit of urban areas, drop in the number of households with high and low incomes, and development of local destination. So you see, this is exactly what we call alternative scenarios. So we try to describe things that are quite different. So I skipped that, but there is an evaluation on the consequences on quantity indicators, housing demand, mobility, short distance, long distance demand, equipments. And then we embed that in our model. And what one of the very interesting indicators that we have is the marginal cost of the CO2 abated. What is this marginal cost? It says that if you reduce 1 more ton of CO2, it would cost you a certain amount of money. I suppose that you are familiar with that. So this is the constraint that we have, because we look at the impact of the different lifestyle at the horizon 2072, and we put a constraint because we want to be carbon neutral at this horizon. So this is the constraint that we put on the level of CO2 emission. And here we have represented the marginal costs of CO2 for the two scenarios. And very quickly, and the most important result that we had is the fact that the marginal cost for the digital society is 700 times higher than the marginal cost for the collective society. So this marginal cost indicates what is the effort that you need to do in order to abate 1 more ton of CO2. But anyway, in the two scenarios, we are doubtful about the fact that we will reach the carbon neutrality because the marginal costs are very, very high. So this is the kind of message that can come from such a model. Just to conclude, I will talk about this red team scenario. So this is a completely different way of making scenarios. So as I said, it was asked by the DGA, the Ministry of the Army, and there were these the cartoon makers, c'est ça, les dessinateurs de bande dessinée, yeah, cartoon makers that were imagining something for the future, and we as scientists, we were there just to tell them this is stupid, or this is infeasible, or this has already been done, or whatever, and to critique their proposal. And I would like to show you one of them, which was called After the Carbonic Night, because that was the one I was involved in, and I was very, how can I say that, very surprised by the scenario itself, because maybe I'm going to show you the scenario, and then we can talk about that. Okay? You will tell me what you think. So I hope you will hear that, because no, we don't care because it's in French. So you just have to read the subtitles. Oh, they speak French. So good. Good. So you should have told me that at the beginning, because it would have been more easy for me. Okay, so I put the... Je vais mettre le son. Ah oui, avec le micro. Ok. Ah non. Come on. You hear?
En 2000. 2035, la situation écologique mondiale est aussi critique que prévu par les projections réalisées dans les années 2020. Au cœur de l'été, une série de méga-feux plonge la totalité de la planète dans la pénombre. Après cette nuit carbonique, la prise de conscience que la décarbonation de l'atmosphère est une question de survie est cette fois mondiale et ne souffre plus d'exception. En 2038, le traité de sobriété et décarbonation énergétique rédigé par le Kétégan est signé par les principales puissances. Chaque nation met en place un département énergie qui donne le la aux politiques publiques. Les armées n'y échappent pas et doivent justifier chaque dépense énergétique utilisée selon un dispositif de seuil de joule autorisé en fonction de la menace. C'est le dispositif ENCON. Les tactiques évoluent, l'équipement aussi. Un nouveau type de combinaison équipe les soldats, l'ENSKIN. Cette dernière permet d'optimiser l'énergie consommée et produite par le soldat. Dans ce contexte, un pays allié du Kétégan au sein des îles péninsulaires, le Kundani, est menacé par Tidaksa, un empire ayant une politique ouvertement expansionniste. En 2050, le conflit éclate. Un corps expéditionnaire kétéganais est missionné au Kundani pour soutenir son allié face à des rebelles soutenus par Tidaksa. L'objectif du Kétégan ? Traverser le Kundani pour aller exfiltrer des scientifiques kétéganais de la vallée de la Corne, livrés aux exactions des rebelles. Mais 4 heures après le départ du corps kétéganais vers le cœur de Kundani, les rebelles attaquent dans la ville de Panlax. Ces batteries étant massivement détruites, le corps kétéganais progresse quand même en utilisant les oasis énergétiques du terrain. Le harcèlement de l'ennemi est constant. Les Wenzi, des nanodrones en forme de moustiques, sont notamment déployés pour décharger les Enskins des troupes. Le corps kétéganais est confronté à une guerre d'usure. Face à la débauche d'énergie de l'ennemi, le corps kétéganais a pour lui son agilité énergétique. Au 9e jour, la mousson s'abat sur le corps kétéganais qui, en mode basse énergie, s'enfonce dans la forêt tropicale. Les forces spéciales kétéganaises localisent et mettent hors service la centrale nucléaire mobile de l'ennemi. Le combat devient davantage symétrique. Au matin du 15e jour, le corps kétéganais arrive dans la vallée de la Corne alors que l'invasion tidaxienne du pays a commencé. Le pays entier est pris sous un déluge de bombes et d'eau. Dans la nuit, le corps kétéganais parvient à évacuer les scientifiques vers le toit d'un bâtiment. Ils sont exfiltrés par hélicoptère, mais les ressources énergétiques manquent pour évacuer le corps kétéganais. L'opération a malheureusement duré trop longtemps. Avec si peu d'énergie, le corps kétéganais réussira-t-il à échapper aux forces d'invasion ?
Very army. Okay. So, what is interesting here is what this guy had in mind for me. I was very shocked because they thought that they proposed to wait until 2038 to elaborate a convention between the states after this carbonic night in 2035. So we have done this like, I think it was 3 years ago. So the vision was, for me, a vision very late, according to what we know. And oui, le micro, sorry. So did you hear me? Yes. Okay. So for me, it was very late to make an intervention in or a coalition in 2038 because there were these mega fires. That was a proposal that was like a denial of all what we know, all what we knew at that time. And another thing that strikes me today is that use of drone. The drones are not used at all in the scenario, and you see that in a real war like Ukraine, drones are really a mean that is at the center of the conflict. So you see that it's just to make you realize that imagination is something that has many biases, and in fact the problem in that perspective approaches is that you need to imagine what is non-imaginable. And that is the most difficult thing to do. And this is how you can really enlighten all the possible futures. Because if you just describe the possible futures as what we are in today, then it has no interest. Okay, so I will conclude like this, and I would be happy to have some questions.
First of all, thank you. And I'm actually curious about the alternative lifestyles that you mentioned. You talked about them like really quickly, and what I want to ask you is, can you walk us through the process that you thought that we as a society can walk through these alternative lifestyles? Like, how can we get there? And they seem to be mutually exclusive, and there's no way that they can be together in a way. And yeah.
Hello, Professor. Thank you. I also have a follow-up question on the previous question. So you showed the two scenarios, the digitalized scenario and the collectivism, and how you are projecting the prospective 2072 to be. But I'm just curious, how did you technically account for the scenario, the proxies that you have taken? Because these are like much ahead in the future. So I'm just quickly interested to know, how did you account for the data of the two scenarios, or how did you technically compare them?
So thank you for the questions. So first, we have a nice publication that you can refer to. Because yes, I had a very quick presentation when I said that we had several students embedded in the process, meaning that we had several students that were working on each model of needed for the description of the scenarios. So first, in order to build the lifestyles, Thomas Le Gallic, he was behind this work. He made surveys with people, and he asked them to describe alternatives, visions, and from this survey, he has constructed the description which is completely qualitative description. Then from that description, we used what we call an input-output model that has been developed by François Briens, second PhD student. And this input-output model translates the assumptions into activities and into level of consumption of different elements. So for instance, the assumption about the fact that there was share in habitat or single places for people to live were translated in terms of the houses and the apartments and their level of rising over time from 2010 to 2072. And then you see that you have an increase of 34% for the total of the housing demand for the digital society, which is completely natural because people are not sharing their apartment. Okay, so that model has brought that result, but it has brought also the result on the mobility, and then you see that the long distance mobility is in white. It's 10 kilometers and more, and the short distance mobility is more and more darked. From 0 to 1 is black, and then gray, shades of gray. And so you see that, so I didn't comment the current situation, But for the digital society, people are just living there in their home, they're working a lot, they're using virtual means, but a lot of time during their leisure time, they take planes to go very far from their house and to take some vacation. And so this is clear here in terms of the increase of the long distance mobility. And for the collective society, you have that shrink of all the mobility for the scenario. And then you have the same coming for also from that model. You have the evaluation of the index of evolution of annual purchases in terms of furniture, appliances, audiovisual equipment, computer hardware, digital devices, garden furniture. And again, we have published that in, let me see, it was in 18, so it's 7 years ago. So this would change a lot today because we did not take into account the artificial intelligence use that we have today. So a lot of other facts. So this would explode. Okay, so that was the first surveys, then the input-output model. Then in order to do that, I skipped a part important, meaning that in order to fulfill the demand in terms of equipment, mobility, and housing, we need energy. And we have a dedicated model named TIMES that gives us the evolution of the energy mix. And so that has been developed by Rémi and Ariane. So they did that, and from that model, I bring the curve. So that was here, because the model, the energy model, we constrain it in order for it to reach the carbon neutrality for 2072. That was because we wanted to assess a change of lifestyles in order to reach the 1.5 degree objective. So yes, I skipped a lot of things, but that comes from, at the end, two models and an evaluation for PhD students working very, very hard. Yes, thanks.
Hi, thank you also for the presentation. My question is around also these scenarios, and because I feel like when there's a bunch of different scenarios from good to bad, that people tend to think always that the middle scenarios are like somehow like the most realistic, but still okay and good options. And I feel like it's kind of, especially like in climate science and climate predictions, it's kind of neglecting the non-linear consequences also of climate change, and that like 2 degrees is something completely different than 1.5, and 3 is also like something very, very different. And I feel like for many people it's also very hard to imagine a radically better future. And I was wondering how this might also constrain the modeling process of these people.
Hi, I'm Louis from Germany. Very good question by Marlene also. I would also second that. And the other question would be, all the scenarios all go by, we do a big amount of things at the same time, but what about like things that happen in temporal different steps, and what about bifurcations that can come out of one thing that we do now that affects like different pathways in the future later?
Just to be sure that I have catch your question, you were talking about the fact that we can have as a conclusion of this kind of study that we need to be in the middle of the two scenarios that are proposed. This is what you were saying? No.
Yeah, sort of. Like, I'm just wondering, because also you showed that like many people so it has like huge implications. And I feel like for many people it's very hard to imagine like even better futures. And so there's always kind of a skew to the negative side. And I was just wondering how that constrains like the modeling.
Yeah. Yeah. So. Yeah, that's a good and difficult question, because so there is an ongoing discussion between scientists that say that if we present scenarios that are too different, at the end the decision maker will not follow us, because they will say there is too much divergence, and then we cannot believe in any of these. And so what you're doing is not meaningful and not useful. So this is why some people in some project, they try to align the results that they get and to be aligned also in terms of assumptions. And this is the reason why there was the building of these SSPs, in order to have always the same kind of assumption to be to refer to. So I believe this is not interesting, because at the end you don't learn anything really meaningful. And so that's the first point. The second point is a conclusion of scenarios like this is not you need to stay in the middle. It's just, it's more than that. It's first, if we completely change our lifestyle, it's not even enough to get where we want to go. If you want to go there, we suppose that the discussion is about 1.5 or 2 degrees. So it's not even sufficient, and then you need to add that to other requirements. And that says that efforts to be made are very important in order to reach something that will be more than the target that are discussed in the framework of COPs. Okay? Second point, bifurcation. It's impossible to take them into account, because we don't know them when we're talking together. And the interest of such a modeling approach that I did not describe in detail is the fact that it is based on optimization. So I can also make a very long description of the paradigm of optimality, which for me is very interesting, because the scenarios that we are constructing are based on the assumption that you have one planner that decides for everybody with a criteria which is the best cost-efficient choice for the technologies. And according to that, we suppose that everybody will follow what is decided by this unique planner, which is absolutely not the case, even in a region, in a country, or in the world. And what we say is that this gives a baseline, meaning that if there was a unique planner that was deciding for everybody at the best cost, then it's difficult to reach the goal. So imagine what is the reality for a world where there are many agents that are deciding not in the same direction. So it will degrade, it will bring results that are worse than the one that we are showing. So the interest of understanding the paradigm that are behind the models brings you another element of interpretation in the discussion you have with the decision and policy makers. This is why it's very important to master the model, to master the assumption and to elaborate on them, not in order to bring any result, but in order, remember, to enlighten and to have discussion. For instance, very quickly, we had a study in 2010 for the French government just after the triple disaster of Fukushima, and when Germany has decided to phase out from nuclear. And for the first time, because in France it was completely non-discussion possible about phasing out from nuclear. For the first time, there was willing to see what would become the energy mix if we phase out. And the result of the models that we have was that nuclear power was replaced directly by coal. And they told us, I remember that meeting, they told us, whoa, you can't show that, change that. Please change it. So it's very easy to change the result with an optimization model. You just put another constraint, or you put a tax, or you put whatever. But that was the most interesting result I've ever had, because Germany phasing out from nuclear was transitioning or using, or is still using, coal. It's something that is extremely relevant in terms of cost efficiency criteria. So you see that in these kind of scenarios, you will pick few elements, not a lot, and it will certainly not give you what is the answer, but it can help you to test options and to have some enlightenment. So I don't know if, I think I have lost the second question from the German guy.
So our scenarios always map this as everything happens at one time. And what about scenarios where things happen over a temporal time?
Okay.
And also what about then in that scenario, or that type of mapping, what about bifurcations? If we do like lift the European debt right now, the outcome doesn't have to be positive. It could also be like a backlash.
Yeah, because it's in the construction of the model themselves. For instance, the model I'm talking about, it's an optimization model that is derived in one time for 50 years. So you cannot integrate anything, you know, step by step. It's just the question of the way the model treats the temporal dynamic. And I don't know any, so that you have some simulation models, maybe, that can integrate bifurcation of or new elements over time, but most of them, they don't work like that. So, and if you do that, you know, you need to have strong assumption. What will you introduce when? Like in 2042, you have an insight of what? You know, you need to be very, very precise. And then we come back to the discussion I had at the beginning of the lesson about prediction versus prospective. So it's difficult to test. For instance, geopolitical instabilities, or when Trump will leave, what will happen? Yes, but at the scale of this kind of path, I think it's, you know, the more you put into your model, the less you have good information. It's very very relevant to have simple assumptions, even if they are not very elaborate, and to see where it brings you. Because if you put more and more and more elements at the end, to interpret the results, it's becoming very, very, very difficult.
Hi, I'm Jonas from Switzerland, and I have a question on the design and selection of like integrated assessment models, because I mean, I would say like there has been a long debate going on, like especially around like working group 3 in the IPCC, which I would argue is by far not in any way neutral, but like it has implicitly a lot of, or like conveys a lot of political and also ideological assumptions and so on in the selection and of models and so on in the first place. And so I was wondering, like, I mean, there are like several aspects that come to my mind. First of all, like the heavy implementation or assumption that we like there will be a heavy usage of BECCS, bioenergy and carbon capture and storage in the future, which, I mean, isn't like a concept that comes out of engineering, but it was actually like that a Swedish economist came up to kind of think on how you can make money with CO2, right? Like, or like how to make that economically viable. And now, I mean, almost all scenarios heavily rely on that, which my theory behind it is just that's how you can avoid this systemic discussion, whether like we like in a growth-prone capitalist society, like we can even overcome the climate crisis. And this leads me kind of to the next one, is that as far as I know, or almost none of the models and scenarios incorporate or even try to incorporate degrowth into that. So degrowth, a degrowth scenario, yeah. So that's like that's the thing, because I think these integrated assessment models, they very much shape, I mean, first of all, as like for policymakers, but also like I think as a whole society on how we think as possible futures and how to combat the climate crisis, right? I mean, like, and like with the SSPs, like the scenario that has the lowest growth is the one that we definitely don't want to be in. So I think that's kind of the messages is also transporting them. And then the other thing is that like a lot of the models that are used, they're still not SFC, like structural consistent. I mean, like they still have sometimes black holes. And a lot of them have like very strong neoclassical assumptions of like rational agents, like optimization over several times, like maximization of utility functions and so on. So my question is like, do you agree with that criticism? And do you see like, or do you see any change in the process of the IPCC in the future, especially now that we are again in the 7th assessment cycle, and like they, I mean, looked already a bit in the 6th that they would kind of try to tackle this problem, but in the end, I think the outcomes were again the same as in the 5 months before. Sorry for this long question.
Hello, I'm Florian from Germany. I have a question about the construction of those SSPs. So in your whole presentation, you said we can think about a future like a game in which the rules are modified and the pieces are moving and so on. And the message for me was like the future is very open. But when I think about climate change, I think about it as something that actually closes the future, because the greenhouse gases that are already in the atmosphere, we can model them quite well, and they somehow determine and constrain our future spaces, and we already know like the impacts that with a certain certainty. So my question would be, do you know if in the construction of those SSPs the damages that we already know will happen, because we already can see we have those greenhouse gases, if those damages are already included in the construction of those scenarios?
Thank you. Very interesting questions. So for the first one, there was, I don't know if you know Jean-Baptiste Fressos. He's a French historian, and he published a paper in early September, I think. And it was exactly what you were saying about IPCC. And he was attacking Working Group 3 and the fact that there were a bias in terms of technology and it's I will send the reference of the paper. It's in English. But the arguments he used were very poor from my point of view. So we had a debate on the radio that was funny because he used as indicator the frequency of appearance of CCS in the text, and this is exactly why I have insisted on the fact that in the chapters you have many material, but it's not because you cite like 100 times one word that it's good. So first, in the IPCC summary, it is said that CCS and BECS and whatever must be used at the very end, when you have done all what you can beforehand. But your remark is completely relevant regarding the fact that it's used more and more in the models in order to reach the target of neutrality. And I can say that for me it's funny because before it was not specified technologies that were used in the models. It was something that people were naming to be defined. So you had a technology TBD, and that was saying, okay, we believe in engineer, and so they will find something. We trust in them. Because a lot of these models are developed by people that are more economists. As an engineer, I can tell that you cannot trust so much engineer because there is a limit. So I'm kind of agreeing with you that there is a reform that has to be made in the way scenarios are presented. And behind my presentation there was like a little critic about that. And also because they are biased. So I was talking about the neutrality of scientists, but it's very difficult to be neutral. Everybody is born somewhere, everybody has an education, believes in a country, and so, you know, it's very difficult for everybody to do that. And so there is bias, that's true. First bias of IPCC is the fact that it's very difficult to have a good representation of the scientists over the planet. So most of the scientists come from the developed region. The papers are published in English. They belong to journals that are very expensive. Not everybody can access them. A lot of publication in the native languages, China, Russia, etc., high scientists are not appearing. So there are a lot of critics that can be made. And I will not develop my answer regarding that, but to say that I didn't want to be part of the 7th IPCC report. So for the degrowth point, we have embedded degrowth in our modeling approach. So we had a PhD thesis a long time ago when nobody was talking about that. And you're completely right. The models that are used, and I didn't have time to develop that, are based on a growth. So the one I talked about is a bottom-up technological model and optimizing bottom-up technological model. A lot of economics model are optimal growth model. So meaning that they are working on control trajectories according to an optimization based on the fact that you maximize your utility function. And the more you consume, the more you're happy. This is what the planner wants for everybody. And so the way it is written is completely orthogonal to the degrowth option. This is why it's impossible to try to test degrowth with that kind of model. You need to develop a specific model to capture the degrowth option. And this is so this is what François, my PhD student, tried to do. So he spent 4 years to develop a model. Okay, so you know it's very frustrating because at the end you don't have time to make scenarios and to demonstrate that it's valid. But you have more and more studies on that. I think what you need to remember is the fact also that what I have presented as this prospective approach is a philosophical approach, and then I skip how I link that to the modeling approach. But a modeling approach is something very small regarding this prospective approach. It's like something that you use because you don't want to fall and you have a stick in order to help you to walk. But it's just a stick. So you can't believe just in models bringing the vision and the solution. And I think that we have used the policy and decision maker to rely on these scenarios, to see them like the guides, but they are just part of the reflection. And so I think for the degrowth, I'm not even sure that it's a model that can be useful, because it's difficult to capture degrowth, because I think François, his PhD thesis is in French, but he has some papers. But if you discuss with people, different people in the degrowth community describing degrowth, they are not, they don't think the same way. They have opponents, in the way they present options. So that's interesting to see how it's difficult to represent that. Okay, so for the other question, yes, you were saying something about the beginning of. Yes, please.
Yeah, so you said like the future is open.
Yes, I remember. Yeah, and it's not open. Yeah, and the yeah.
And is this included in the?
Yeah, that's true. So yes, so there is in French. Okay, so there are some people that believe that the future is already written. In some culture, in my culture, in Arabic, you say mektub, meaning that you don't have to do anything. Just wait, because it's written for you, for your life, you personally. So you can try to go there or come back here. It's going to be the same. And so what you're saying make me think about that. Saying that, okay, there is this huge problem, and so it's written because we have a constraint on climate. So, yeah. Go.
Only the part of the gases that are already in the atmosphere, they are written there.
That's true. Yeah. No, but I was coming back to that. So what is true is that for the SSPs, I agree with you. When the people, they have written that, it was in 2014. And first, I think they did not embed that in their scenarios. Second point, I didn't say that. 60 people, most of them male, white, from North. So I'm sorry, I think it's not a good way of trying to imagine anything. And then I think today, and the more we progress, the more we need to integrate this knowledge in the way we are thinking. This is why, from our point of view, we have make bifurcation between tackling attenuation, mitigation, only mitigation, mitigation, and now we are working on adaptation, and more on adaptation, because it's here, it's there, and we cannot just talk about like, oh yes, we are decarbonizing. Come on, people, it's too late. Or you can continue to try that, but you have also to consider other elements. And what we have also integrated is the question of biodiversity. So we try to have more a holistic approach, integrating more and more elements. This is why personally I think models are nice, but they are just like one piece of the puzzle. And it's important not to rely only on that, and just to understand what is behind the curves that everybody brings and show, yes, we are in this trajectory, we are in the past, we are there, we're... Okay, it's not enough now to discuss. So I agree with you that that has to be integrated, but I still would like to believe that we are capable of still building our future.